now we get to question 9. This is also kind of an application of the Newton's third law again, but the wording is pretty tricky and is often missed by students in introductory physics classes. It presents this kind of a scenario. A horse exerts 500 newtons of force on a heavy wagon. Okay, so imagine the horse. Behind the horse, there's a wagon. The horse is trying to carry the wagon. The wagon pulls back on the horse with an equal force. Is that true? Yes, that is true. That's an action-reaction, right? So the wagon pulls back on the horse. Third sentence, the wagon still accelerates. Okay? Or does it accelerate, or does it not? Well, the question says the wagon still accelerates because A, these forces are not an action-reaction pair. They're not an action-reaction pair. Are they not an action-reaction pair? Okay, the force pulls on the wagon pulls on the force back. Is that why the wagon still accelerates? Is it because they're not an action-reaction pair? Or choice B, nevertheless, there is still an unbalanced force on the wagon. So there's some kind of unbalanced force on the wagon, net force that's causing the wagon to accelerate. Choice C, the horse pulls on the wagon a brief time before the wagon reacts. So this one is basically saying that when there's an action-reaction pair, the action force is actually a little time before the reaction. So there's a little gap. So that gives the chance for the horse to accelerate the wagon before the wagon pulls back on the horse. D, the wagon does not accelerate because these forces are equal and opposite. So choice D says there's no way. If this is happening, there's no way that the wagon is going to be accelerating. It's going to stand still because these forces are equal and opposite. So which one is the answer? Think about it a little bit. The answer is going to be choice B. Nevertheless, there is still an unbalanced force on the wagon. Okay? This one is the answer. There is still an unbalanced force. What's happening here? If we draw the vectors, so you have a horse here. Just draw a quick horse. Okay? So then there's a wagon here. The force is pulling on the wagon with a 500 Newton force. The wagon pulls on the horse with 500 Newtons. Right? So it is an action-reaction pair. Choice A is wrong. But then why does anything accelerate? Well, the force on the wagon is 500. There's an unbalanced force on the wagon. Maybe there's a little bit of friction force on the tire, maybe 100 Newton or maybe less. But you see, the net force on the wagon is what? 500, 100. So the wagon is accelerating, right? Now, why is the horse accelerating forward? The horse got to accelerate forward also. Well, the horse is exerting a force on the ground. Some sort of force, right? So the force that the horse exerts on the ground must be something that is greater than 500, right? Maybe the force is equal to 700 Newton. So the horse pushes back on the ground pushes the horse forward, 700 Newton, okay? And then the horse is able to exert a 500 Newton force on the wagon pushes back on the horse with 500. What's the net force on the horse? 200 Newtons forward, okay? Right? And then we could get more specific in detail. We could say, what's the mass of the wagon? What's the mass of the horse? And then if they're going to accelerate together, what should those forces be so that they have the same acceleration? You can get more detail about that. But for now, let's just say that the horse accelerates because the horse exerts a greater force on the ground than the horse exerts on the wagon. The ground pushes the horse forward. The wagon pulls on the horse backward. But the net force on the horse is still forward. The net force on the wagon is still forward also because you have 500 and then maybe the force of friction. And then so the difference of the two is still forward. And what is that going to be? 500 minus 100? 400 Newton, right?